Assalamu alaikum warahmatullahi wabarakatuh. We are discussing chapter number 8, electricity. So let's see what are the uses of gold leaf electroscope. First is to check the presence of charge on an object using uncharged gold leaf electroscope. So this is a gold leaf electroscope, it is uncharged, and this is object A. When this object A is touched with the metal disc of this uncharged electroscope, then what happens? If there is no movement in the gold leaves, these are the gold leaves. If there is no movement in the gold leaves, it means object A is uncharged, and when the leaves diverge. So here the leaves are showing divergence. So it means that object A is charged. Because when object A is charged, its charge is shared by the disc, metal rod and the leaves. The charge is shared by the disc, rod and gold leaves. And due to the presence of like charges on the leaves, they diverge. Now next is to identify the nature of charge. When the object is charged, which type of charge is there, positive or negative? So take a gold leaf electroscope and let it be positively charged. Now touch the object A to the metal disc of the electroscope. Now we have to observe the movement of gold leaves and the gap between them very carefully. So when the gap between the leaves increases, it means that the charge on object A is positive, and when the gap between the leaves decreases, it means the charge on the object A is negative. Now the electroscope is charged negatively, and when the object A is touched to the metal disc, what happens? If the gap between the gold leaves increases, it means the object A is also negatively charged. If the gap decreases, it means the object is positively charged. Now what is atmospheric electricity? There was an American scientist, Benjamin Franklin. He was the first to prove that clouds get electrically charged during a thunderstorm. So he made a kite of silk cloth. Then he fixed a pointed metal wire about 30 centimeters long at the top corner of the kite. The other end of the wire was attached to the string, and at the lower end of the string he tied a metallic key. This is the wire, and this is the key attached to this wire, and this is a silk strip to insulate the string from the earth. Then during the thunderstorm, when the kite reached high enough and string got wet due to rain, he observed a number of sparks between his knuckles and the key. He got an electric shock when he touched the metal key. This is because during a thunderstorm, the clouds get charged due to friction. Due to friction, these clouds get charged. So this charge flows through the metal wire and the wet string to the metal key. Thus, the charge gets collected on the key here. When the knuckle comes near the key, it gets oppositely charged by induction. So when the metal key was touched, heavy charge flows to the earth through the body, giving an electric shock. So this experiment led him to invent a safety device which is called the lightning conductor. Now what is lightning? During a thunderstorm, the clouds get charged, and whenever a charged cloud passes over an uncharged cloud, what happens? Due to induction, the uncharged cloud acquires an opposite charge. So when two oppositely charged clouds, they come close to each other, there is a heavy flow of charge between them. As a result, there is release of energy in the form of light, heat and sound. So during a storm, we can see lightning and we can hear thunder. So a lightning discharge may be very dangerous. It can cause fire and it can also shatter buildings. So at the time of lightning, what happens? Heat is produced. So the air also gets upheated and it expands suddenly. And due to this rapid expansion of air, there is a disturbance which is in the form of vibrations through the air, and it produces a loud sound. As we know, sound is produced due to vibrations. So due to sudden expansion of air, what happens? There is a disturbance, and this is in the form of vibrations, so it produces a lot of sound, which is called thunder. Now the rapid flow of electric charge through the air between two oppositely charged clouds, it can be seen in the form of a spark of electricity, and this spark of electricity is called lightning. So an electric discharge or lightning can occur not only between two clouds but also between a charged cloud and the earth. So a cloud has a negative charge which is concentrated at the base and positive charge which is concentrated at its upper region. So whenever a charged cloud passes over a tall building or a tall tree, what happens? It induces an opposite charge, that is negative charge on them, because its upper region is positively charged. So when the negative and the positive charges they connect, they form a continuous path from the cloud to the tall building or the tree on the ground. So the large amount of negative charge which is accumulated in the clouds, it rushes down through this path and it gives rise to an electric discharge, that is lightning. So when the electric charge flows between a charged cloud and a tall building on the earth, we can say that lightning has struck in the form of a lightning strike. Now what are the harmful effects of lightning? Lightning can cause fire and shatter buildings, and it results in a lot of destruction and damage to the property. It can burn trees and can cause forest fires. And it also injures and sometimes even kills animals and people instantly. Now what is lightning conductor? It is a device that is fixed at the top of the tall buildings to protect them from being damaged due to lightning. This is a lightning conductor. Now this is lightning conductor. It is made up of a long rod of iron or copper, and it has a number of sharp long pointed spikes at the top end, and this rod runs from the top to the bottom along the outer wall of the tall building. Then the lower end of the rod is connected to a metallic plate which is usually made of copper, and this copper plate is buried deep inside the earth to provide a good connection. So when a charged cloud passes over the building which is fitted with a lightning conductor, what happens? Due to induction, an opposite charge is induced on the spikes, and this charge passes to the earth through copper rod. So this prevents the lightning strike and thus it saves the building from being damaged. Now what are the safety measures to be taken during lightning? Whenever there is a thunderstorm, there are some safety measures to be taken. And now outdoor safety measures are: during thunderstorm, rush to a safer place, and a building or a car with closed windows could be an appropriate shelter because the body of a car acts as a conducting path for the lightning discharge. And do not lie flat on the ground. Do not take shelter under a tree because trees provide a good conducting path for lightning discharge. Whenever you are in a group of people, stay about 15 feet away from one another. Stay away from all types of water bodies because water is an excellent conductor of electricity. Open vehicles like scooters, motorbikes, tractors and open cars do not protect us when lightning strikes. And quickly come down from elevated places like a hill, the summit of a mountain or the rooftop of a building. Whenever you are in a forest, take shelter under shorter trees that are less likely to be a site of lightning strike. appear as small as you can by crouching on your knees on the ground. Place your hands on your knees with your head between the hands. This position will make you smallest target to be struck. What are the indoor safety measures? Do not use electrical appliances like televisions, air conditioners, and computers. Electrical lines are excellent conductors of electricity, so unplug these electrical appliances. Do not take bath or shower during storms, as water is an excellent conductor of electricity and lightning can strike telephone cords, electrical wires, and metal pipes. So during a thunderstorm, contact with these objects should be avoided, and it is safer to use mobile phones and cordless phones. So stay away from plumbing lines. Such pipes are generally a conducting path for the lightning discharge.